Today we are going to solve the hydrogen atom problem for zero and non-zero angular momentum. The hydrogen atom is a very simplest case. It has only one proton and one electron. Proton is a heavier particle. The mass of the proton is 2000 times, approximately 2000 times higher than that of the electron. The Hamiltonian for the hydrogen atom is capital P squared over 2 capital M. The capital letter indicate term indicate for proton and small term is for electron. That is plus P squared over 2M, small m. This is the kinetic energy of proton, this is kinetic energy of electron, plus the potential energy. See, this term, second and third term is relative coordinate system. That is, this is relative coordinate system. Relative coordinate system. And first term is for center of mass coordinate. Center of COM, center of mass coordinate system, but it is almost stationary. So since it's a heavier particle, we can consider this as a stationary state. So we are dealing only with the relative coordinate system, that is for the electron. So the potential is for relative coordinate system, that is central field. So the V of R is equal to minus E squared over 4 pi epsilon naught R. Here another important thing is you can calculate the reduced mass. Reduced mass is equal to capital M multiplied by small m over capital M plus small m. Comparing capital M, this small m is negligible, so you can cancel this. Now this capital M and this capital M is get cancelled. This capital M and this capital M will get cancelled. So the reduced mass is equal to small m. That is the mass of electron. So we are going to deal with only with the electron. That is relative coordinate system. First we will see solve the hydrogen atom problem for zero angular momentum. First, we will see the case of zero angular momentum. The radial part of the Schrodinger wave equation is minus h cross squared over 2m 1 over r squared t by tr of r squared t capital R over tr. Here the capital R is radial part of the wave function, plus L into L plus 1 h cross squared over 2m r squared plus V of r. This is a centripetal term. Then V of r is the potential energy multiplied by r, which is equal to E of r. Here you just replace the V of r for hydrogen atom is this one. We have already seen, that is V of r is equal to minus E square over 4 pi epsilon naught r. So now you multiply this expression by minus 2m over h cross squared, minus 2m over h cross squared. Then this will become plus 1. Then the remaining term is 1 over r squared t by tr of r squared t capital R over tr. Then you multiply the right hand side by minus 2m over h cross squared and bring it to the left hand side. So this minus will become plus 2m over h cross squared E of r minus 2m. Here you have 2m over h cross squared minus this. I have replaced the potential R of r, which is equal to 0. Of course, we are taking this angular momentum as 0 angular momentum. So this term, centrifugal term, is 0. So we got this expression. Now you take the first term and differentiate. So if you keep r squared as it is and differentiate this tr over tr, then this will become second order derivative. Here this r squared and this r squared will get cancelled. Then you differentiate r squared. If you differentiate r squared, you will get 2r, and there is 1 over r squared here. So you keep this differential term as it is. Then here 2 r will cancel with this r squared. This will become 2 over r, and this tr over small tr, and you are retaining this term as it is 2m over h cross squared er, and here minus of minus will become plus, plus 2m over h cross squared e squared over 4 pi epsilon naught r of r equal to 0, because we brought this term e term to the left hand side. Now you take the entire thing is a constant. So you keep that constant as lambda. That is, lambda is equal to 2m over h cross squared e sub r. So this is lambda. And here the variable is 1 over r. Remaining thing you take, this is remaining thing is constant. So this you keep as alpha. So alpha is equal to 2m over h cross squared e squared over 4 pi epsilon naught. So this equation can be rewritten as the first two term we keep as it is, third term will be lambda, fourth term will be alpha over r, this r, alpha over r, then multiplied by r of r, which is equal to 0. Now we got this expression T2R over TR2 is equal plus 2 over R TR over T small r plus lambda plus alpha over R multiplied by R of R is equal to 0. A solution for this equation satisfying the standard condition, that is, the solution must be finite everywhere including R equal to 0, and must tend to 0 at partially infinite, that is r tends to infinite. Hence the normalized solution is in the form of r equal to e power minus beta r. So in this case, if r equal to 0, this will be 1, this wave function. If r is infinite, it is naturally 0. So it satisfies the boundary condition. Then what is the first order derivative? Tr over Tr small r is equal to minus beta e power minus beta r. Or we can write that minus beta r. So in similar way, the second order derivative is that is T2 r over Tr2 is equal to beta squared r. So this is plus beta squared r. You replace this here. So the first term will become second order derivative is equal to beta squared r, and this first order derivative is minus, because minus beta r, minus 2 over r beta r. Then this third term will be, you are keeping the constant as it is, that is the terms inside the bracket, lambda plus alpha over r of r is equal to 0. Now you can cancel this r of r in all three terms. So this will become beta squared minus 2 over r beta plus lambda plus alpha over r, which is equal to 0. Now we got this expression. Now you can separate the terms with r and without r. That is, without r we have beta squared and lambda. So beta squared plus lambda I have grouped one. Then the terms contain r. Here you have 2 over r minus 2 over r beta. Here alpha over r. So you take 1 over r as a common, then you have this alpha minus 2 beta, which is equal to which must be equal to 0. This is possible only this term is equal to 0 and also this term is equal to 0. So this is valid for any r. So naturally using the first term, beta squared must be equal to minus lambda and alpha is equal to 2 beta. Alpha is equal to 2 beta. Only if two conditions met out, then only it will become 0. Now we don't know the beta value, but we know alpha. We have defined alpha and lambda. So we bring the result in terms of alpha and beta. So from this expression, beta squared, uh, you can just square this one. So alpha squared is equal to 4 beta squared. So naturally, or you can rewrite this as 4 beta squared is equal to alpha squared. So you know beta squared is minus lambda. So the left hand side will become minus 4 lambda. Right hand side you keep as it is, which is equal to alpha squared. So minus 4 lambda is equal to alpha squared. Now we know the value of lambda and alpha. We have defined what is alpha and what is lambda. So we got this expression minus 4 lambda is equal to alpha square. Already we have defined lambda and alpha. Lambda by definition is equal to 2m over h cross squared E sub r. So 2m over h cross squared E sub r. Similarly, alpha squared, we know alpha is equal to 2m over h cross squared multiplied by e squared over 4 pi epsilon naught. So we are squaring this. So 2m over h cross squared multiplied by e squared over 4 pi epsilon naught whole squared. So here you can see, you can cancel this 2m over h cross squared with this 2m over h cross squared whole square. This square will get cancelled. So minus 4 e of r is equal to 2m over h cross squared e squared over 4 pi epsilon naught whole square. Now you bring this minus 4 to the right hand side. This 2 4 will get cancelled, so which will become minus m over 2h cross squared, because this 4 will get cancelled with this 2, e squared over 4 pi epsilon naught whole squared. So if you substitute this value, all are constant, so which is equal to minus 13.6 electron volt, which coincide with ground state energy in fourth area of hydrogen atom. So this is the validity of our approach. Now we will move on to non-zero angular momentum. Now we will see the case of non-zero angular momentum. In the case of zero angular momentum, we have used radial wave equation. Here we are going to use reduced radial wave equation. That is minus h cross squared over 2m T2u over Tr2 plus V of r plus L into L plus 1 h cross squared over 2m r squared multiplied by u of r, which is equal to u of r. Here u of r is reduced radial wave function. By definition, the reduced wave function divided by r is equal to the radial part of the wave function. That is r is equal to u over r. Now you multiply this by minus minus 2m over h cross squared, 2m over h cross squared. So now this first term will get cancelled. That is, you are multiplying by inverse of this. So this will become plus 1. So the second order derivative of u, and this will become minus 2m over h cross squared v of r. We know the potential for hydrogen atom is minus E squared over 4 pi epsilon naught r. the terms inside the bracket. Now the remaining term, here you can see the third term you have 2m here and h cross square. So you are multiplying by minus 2m over h cross squared, inverse of this. So this will become minus L into L plus 1 over r squared, because h cross squared will get cancelled, u of r, which is equal to minus 2me over h cross squared u of r. Here we are going to take this as alpha. This is alpha. That is, alpha is equal to square root of minus 2me over h cross squared. And also we are going to cancel this 2 with this 4, which will become 2. So you have in the numerator minus of minus will become plus, and me squared over here you have 2 pi epsilon naught, and this h cross squared will come over r, u of r minus L into L plus 1 r squared u of r, which is equal to alpha squared u of r. So we got this expression with alpha is equal to square root of minus 2me over h cross square. This approach is essentially the same as in the case of analytical solution for harmonic oscillator. While there are both continuum, that is E is greater than 0. If E is positive, this square root is a negative quantity, so it's imaginary. And bound state, where E is less than 0, that is E is negative. E negative means this square root is real, so it is bound state. So when E is negative, it is bound state. For continuous state, E is positive. Here we are going to consider the bound state. For bound state, as I said, E is less than 0. Hence, alpha is real. This alpha is real. Now we will have a dimensionless quantity, rho is equal to alpha times r. Since alpha is having the dimension of inverse of rho, it is rho inverse of length, inverse of the length. So rho is the dimensionless quantity. Alpha, we know the dimension of alpha is 1 over length. So if you multiply 1 over length by length, you will get the dimensionless quantity. So we got this relation. Now, as I said, you replace r with rho, and above equation become, because rho is equal to alpha times r, then t rho is equal to alpha times t r, and t rho 2 is equal to just square it, alpha squared tr2. So which indicate that tr2 is equal to, when you bring alpha squared to the other side, t rho 2 over alpha squared. So substitute all this thing here. So first 1 over tr2, here tr2 is equal to t rho 2 over alpha squared. That alpha squared will come into the numerator. Then similarly, this r, what I am going to do is I am going to multiply and divide by alpha, alpha and alpha. So this will become alpha r is equal to rho. So me squared alpha over 2 pi epsilon naught h cross squared rho, u of rho. Then this is equal to, now I am going to replace r is equal to rho by alpha squared. So r squared is equal to rho squared by alpha squared. Alpha squared will go to the numerator. Here you have alpha squared. Now you divide by alpha squared. That is, then this alpha squared, and here this alpha squared and this alpha squared will get cancelled. In the third term, you multiply and divide by alpha. So this alpha squared will get cancelled. We are getting this alpha. So we are multiplying and dividing by alpha. So numerator will become alpha squared, and which will get cancelled when we are dividing by alpha square, and there is a alpha here. So this equation can be rewritten after dividing by alpha squared T2u over TR2 m e squared over 2 pi epsilon naught h cross squared. This is alpha because we are replacing, sorry, here you have alpha, we are dividing by alpha. So alpha rho, you have rho is a variable, u of rho, plus you will get L into L plus 1 over rho squared u of rho, which is equal to u of rho. Now we have to solve this. Before that, the terms inside the red color rectangular box, we are defining that as rho naught. Now this will become rho naught over rho. Second term will become rho naught over rho, u of rho. Now we will further simplify this. Now we got this expression. What we are going to do is you take these two terms to the right hand side. So you bring this to the right hand side, and this will become second order derivative of u with respect to rho is equal to, when this goes here, mu rho will become 1 because we are taking mu of rho as common. So 1 minus, this will become minus rho naught over rho. Then this minus will become plus L into L plus 1 over rho square u of r. Now we will see the asymptotic form of the solution. Asymptotic form, now you can take rho tends to infinite, asymptotic form. First you take rho tends to infinite. Then this will be 0. The second term also will be 0. So the T2u of rho over T rho 2 is equal to u of rho. The solution of above expression is well known. We know mu of rho is equal to a e power minus rho plus p e power plus rho. But for second one, for infinite, if e power infinite is infinite, so this is not valid solution. So p must be equal to 0. So naturally, for large value, the wave function mu of r, reduced radial wave function, is equal to mu of rho is equal to a multiplied by e minus e power minus rho. So now we will see what will happen if rho tends to 0. The Schrodinger equation become, that is T2u over Tr2 is equal to 1 minus rho naught over rho plus L into L plus 1 over rho square u of rho. When rho tends to 0, when rho tends to 0, what will happen? Naturally, the centrifugal term will get dominant. So this will be 0. Second term will be 0. So this also negligible comparing this, because the third term will, centrifugal term will dominate. So which is equal to T2u over T rho 2 is equal to L into L plus 1 over rho 2. Here rho is tends to 0, so this will be dominant one. Of course, we have u of rho. The solution for above equation is u of rho is equal to C rho power L plus 1 plus T rho power minus L. So this can be, the second term can be written as T power rho L. So when rho is 0, this will tends to infinite, so which is not acceptable solution, so t will be equal to 0. So this wave function will be valid solution is u of rho is equal to c rho power L plus 1. So we have seen u of rho with the reduced radial wave function is equal to e power minus rho if rho tends to infinite. Then another extreme case is u of rho is equal to c rho power L plus 1 if rho tends to 0. Subscribe to my channel to get my latest videos, and join my channel to support its growth and enjoy the exclusive perks. Also use the thanks button to make one time contribution and support my channel. Thank you very much.